This is lesson 5.3 of accelerated geometry. In this lesson, we're going to talk about kite properties and trapezoid properties. So first, we'll review the definition of a kite. A kite is a quadrilateral. That means it has four sides with exactly two different pairs of congruent consecutive sides. So these two sides here are next to each other and they are equal, and these two sides are next to each other and they are equal, and the two pairs are not equal to each other. So not all four sides are equal. Two are equal here, two are equal here. The sides that are equal come together at a vertex angle. Here, these two sides come together at a vertex angle. And geometry people, again, not being too creative, said if those are the vertex angles, let's call the other two non-vertex angles. So where the non-equal sides come together, those are the non-vertex angles. So there are two non-vertex angles and two vertex angles in a kite. And now I'm going to try to show you the properties. So here is a kite. And if you have your conjecture list handy, we're going to be adding 1, 2, 3, 4, 5, 6, 7 conjectures today. So here is our first. The first says, show the kite angles conjecture. The non-vertex angles of a kite are congruent. So HGE is over here, and angle EFH is over here, and GEF is there, and FHG is there. So we're looking at the non-vertex angles. So the non-vertex angles are where the non-equal sides come together. So this would be one of those angles and one of these angles here. So those are the non-vertex angles of a kite. And conjecture number 34 says the non-vertex angles of a kite are congruent. Now, if I move this, they still stay congruent. If I move this, the non-vertex angles still stay congruent. So anything that I move, the non-vertex angles are always the same. Okay, then we're going on to conjecture number 35. I have to deal with the kite. The diagonals of a kite are perpendicular. Now, how do I know that? Because FIE right here is 90 degrees. So that means the vertical angle across from it is also 90 degrees, and this is 90 degrees, and this, they're all 90 degree angles. But two lines that come together at a 90 degree angle are perpendicular. So the diagonals of the kite, which are HE and FG, they are perpendicular. So that is conjecture number 35. Okay, this one says, this is conjecture number 36. The diagonal connecting the vertex angles of a kite. The diagonal connecting the vertex angles of a kite, right here. What does it do? It bisects the other diagonal. So FI is 0.88 and IG is 0.88. So the diagonal connecting the vertex angles of a kite bisects the other angle. And not only that, I'm adding in there, this is my own little thing here, it's also perpendicular. So if it bisects it and it's perpendicular, it's actually a perpendicular bisector. So conjecture number 36 says the diagonal connecting the vertex angles of a kite is the perpendicular bisector of the other diagonal. Okay, so I'm going to move this stuff out of here. And then I'll go to the next one. So this would be the diagonal connecting the vertex angles of a kite bisects the other vertex angle. So this is conjecture number 37. So where are these vertex angles? Up here and up here. Okay, so FHI is there, FEI is here, GHI is up there. Let me get these guys out of here maybe. Okay, and GEI is here. Okay, the diagonal connecting the vertex angles, that's that guy. What does it do to the vertex angle? So this vertex angle used to be 92.1, but now this diagonal comes through it, and look what it does. It bisects it. Okay, same thing over here. Here's the vertex angle. Here's the diagonal coming down to that vertex angle, and look what it does. It bisects it. So our conjecture number 37 on our conjecture list says the vertex angles of a kite are bisected by the diagonal. Okay, so those are the 4 kite properties and the 4 kite conjectures. Now I'm going to go back to the presentation, and I'm going to go to this slide that gives us a review of some terms. A trapezoid is a quadrilateral, 4-sided figure with exactly 1 pair of parallel sides. It does not have 2 pairs of parallel sides, just 1 pair. Now I have to tell you, some geometry books do say that it could have 2 pairs, but our geometry book and many others just say it has to have just 1 pair of parallel sides. So here are the parallel sides. Those are called bases, and at the end of each base there is a base angle. So here's a base, and here is a pair of base angles. I can also have an isosceles trapezoid. It has 2 sides here that are parallel, and the other 2 sides are congruent to each other. Okay, so now I'm going to go back here and talk about just a regular trapezoid. So here's a trapezoid, and it says, conjecture number 38, consecutive angles between the bases of a trapezoid are. Okay, so here is this angle and this angle. They are consecutive, one right after the other between the bases. So this is a base and this is a base. So the angles between the bases are this guy and this guy. Now, if I add those up, they add up to be 180. Okay, now let's go over here. This angle and this angle are consecutive angles between the bases. Here are the bases, and then these are the angles that would be between them, and they're one right after the other, consecutive. Now look what happens when you add those up. They add up to be 180. So conjecture number 38, consecutive angles between the bases of a trapezoid are supplementary. Now our last 2 conjectures deal with isosceles trapezoids. So not just regular trapezoids, but isosceles trapezoids. Okay, so conjecture number 39 says, base angles of an isosceles trapezoid are what? Okay, here are the bases, and so this would be one set of base angles, the angles on each side of that base. And look at them. They are equal. Okay, here's another base. These are the base angles that go along with that base at each end. Look at them. They are equal. So conjecture number 39 is not written on this screen, but it's on your conjecture list. It says base angles of an isosceles trapezoid are equal or congruent. Okay, our last one. That's not the one I wanted. Okay, this is what I wanted to do here, right there. I'm going to look at the diagonals. AC is 2.30 and BD is 2.30. Now, if I look at them, keep your eyes focused on those 2 numbers, and I move this, those diagonals are going to stay equal to each other. So the diagonals of an isosceles trapezoid are always congruent. That's not the one I want. So that one is not listed on your on the screen here either. It's in your on your conjecture list. Conjecture 40, the diagonals of an isosceles trapezoid are equal or congruent. Now, if I go back, here is the PowerPoint with our notes. If you've missed any of them, any of these conjectures, they're listed as the last page in the PowerPoint for section 5.3. Now, also remember that as you put these on your conjecture list, you have to do sketches to show what the conjecture says.